Hello, and welcome to a special JMR event. I would like to introduce our host, the Editor-in-Chief of Journal of Materials Research, Gary L. Messing. Dr. Messing, if you would kick things off, we will begin.
And thank you for our audience for joining the video presentation of the 2021 JMR Paper of the Year. The Gordon E. Pike Prize for the JMR Paper of the Year recognizes excellence in advancing materials knowledge through written scholarship. It honors outstanding original research published in JMR in a specific volume year, in this case, the year 2021. We are joined today by Dr. Lorenzo Moroni, Dr. Jules Harings of Maastricht University. I'm pleased to present the Gordon E. Pike Prize for the 2021 JMR Paper of the Year for your paper entitled Shaping and Properties of Thermoplastic Scaffolds in Tissue Regeneration, the Effect of Thermal History on Polymer Crystallization, Surface Characteristics, and Cell Fate. There's a long list of authors, and I'll let you deal with those yourselves. It is noteworthy that the paper was a published contribution in the JMR Focus Issue on 3D printing of biomedical materials and devices, edited by Amit Bandyopadhyay and Sushmita Bose. This is the 8th annual JMR Paper of the Year award and comes with a cash prize sponsored by Stephen Moss. I collaborate with the journal's associate editors, Sushmita Bose, Sarah Morgan, and Matthias Bugirken, consider the top contenders and arrive at the winner every year. We all agreed that your paper demonstrated brilliant insights about how thermal history affects thermoplastic material surface properties, and subsequently how these properties affect cell attachment, proliferation, and differentiation on polymers used as scaffolds for tissue engineering. The committee was particularly impressed with how you combine an extensive array of analytical tools used in both materials science and in biomedical materials research to gain useful insights concerning polymeric material cell interactions. Drs. Moroni and Dr. Herring, please tell us a little bit about yourselves and about the collaborative research that you have at Maastricht University. Dr. Moroni?
Thank you, Dr. Messing. Thank you, Gary. First of all, thank you and all the members of the committee for the great honor for awarding us with the prize of this year. I am a biomedical engineer. I am a professor here at the Maastricht University and the Institute Director of the Merlin Institute for Technology-Inspired Regenerative Medicine. And in this work, I was very pleased actually to work together with Dr. Jules Harings, also from Maastricht University, together with a number of PhD students and postdocs of both our groups, as well as with colleagues from the Eindhoven University of Technology, to actually study a topic that is very close to the heart of Jules and I, which is how indeed we can influence in an active manner the mechanical and physical, or physicochemical, better to say, properties of materials to directly influence cell fate, and in particular stem cells fate.
Dr. Herings?
Yes, well, thank you very much also for organizing this, and indeed, like Lorenzo said, for the award on this, let's say, idea that we had that originated in both our backgrounds. So my background is macromolecular physics and technology. I'm heading the group at the Maastricht Institute for Bio-Based Materials. And in my role, I'm mostly interested in the behavior of molecules, particularly macromolecules, during processing and in function. And one of the elements there is to study crystallization behavior of macromolecules during processing using spectroscopy means, where we have dynamic input of light, heat, but also force. And in that sense, we had the opportunity to work together on a common grant, where the discussions basically fed each other. And yeah, Lorenzo stated sometimes, yeah, if we could do this, if we could tune surface properties, and it's not only chemistry, it's probably roughness, intertwined by stiffness, how can we eliminate these factors and study one by one? And that has been, yeah, one of the main motivation to interact. And obviously we can't do that by ourselves. We have specialists in both labs, and we also realize that having such a multidisciplinary approach is not always easy. And I think that explains the number of co-authors on this paper.
Well, it's very interesting, actually. Like I said, the incredible amount of different analytical approaches to this particularly difficult problem, particularly where you're marrying two communities, one which looks at completely different phenomena at the cellular level, and then the other that looks more at the physics of materials themselves. I was particularly struck, and the committee was particularly struck with the very interdisciplinary nature of the group, but I'm also questioning, how do you sponsor, how do you support such a large group of people? I have to admit, geographically, proximity is pretty good, but still in a lot of different laboratories.
Yeah, if I may, Jules, I kick off the discussion, and then please feel free to also add where you see needed. This is a good point. I think we have actually been part of a spearhead program here in the region, where the University of Maastricht, together also with the Aachen University, which is in Germany, but actually just a few kilometers or a few miles for the American audience away from Maastricht, have also joined in collaboration with Maastricht University, creating the Aachen Maastricht Institute of Bio-Based Materials, where Jules works. And at about the same time, there was a great effort to create an interdisciplinary group of people, which founded actually the Merlin Institute for Technology-Inspired Regenerative Medicine, where we work a lot with biomaterials at the interface with cells. So we have a good understanding of how biomaterials work and how can we process biomaterials, but certainly not to the level of deep understanding that the group of Jules actually can provide from a macromolecular perspective. It is known in the field that in the field of biomaterials and regenerative medicine that surface features, especially surface roughness, can have an active influence on cell fate, and particularly on stem cell activity. Indeed, via modulating their adhesion to the materials, and by doing that, changing essentially the machinery inside the cells that actually result in the activity that cells can do, either to proliferate and therefore to multiply themselves, or to differentiate into more specialized cells in the case of stem cells. What was not really clear and understood is what actually is the role of crystal size. And indeed, as Jules explained, oftentimes in the biomaterial field, these different properties, in fact, are intertwined and interplayed, and there is not a lot of effort in trying to discern actually what is the influence of one versus the other parameter. And I think thanks to the expertise of Dr. Haring's group, we were able to really start to make first steps to dissect this kind of fundamental properties, and then also with a nice twitch in the outlook of the paper, where we then moved from two-dimensional materials to three-dimensional scaffolds, and showed in a way how we could also control the change of these properties in 3 dimensions.
Well, very nice. We're gonna stop there for today, but I want to thank both of you, as well as your wonderful research teams, for pulling together such an outstanding contribution to the literature, and also for accepting an invitation to publish in JMR in our focus issue. I hope that with the future success of your group, that you continue to publish with us in JMR, and I look forward to future collaborations. Thank you so much, and congratulations on receiving this award.
Thank you
very much. Thank you.